A very good afternoon to one and all. A very good afternoon to one and all. Today I am Dr. Pallavi Pati, Assistant Professor in the Department of Pharmaceutical Chemistry from Modern College of Pharmacy, Negri. Today I am taking one of very good topic and very interesting topic, that is Introduction to the Chromatographic Separation. Now, introduction of the chromatography separations means what? There is one of a very good invented technique named as a liquid chromatography. Two type of different samples we can separate it from each other. Okay, and on the basis of this, we are very genuinely invented one of the researcher, that is a Russian researchers, Tisvil, in the 1903. He has invented a very good color chromatography on the basis of the Greek. Chromo means a color, graphic means how to write, the way of separation on the basis of the absorptions of different color or bands. We will see let's see the different type of chromatography on the basis of this. Now you can feel that this is a single column type, okay, a glass columns, and you feel that there are a different type of name we are designed in such a way in the combination of this, that is xanthophenyl, then chlorophyllene, beta, or different type of. Now these are the derivatives of xanthophyll. Now if you want to separate one derivative from the different type of compounds, you can separate with the very simple technique, that is a chromatographic technique. Now in this video you will feel that this is a very good technique, very simple technique to understand the path, to understand the fundamental functionings of this. Now all these different type of compounds having a different type of colors, and when you feel this combination of a compound in the column and let it settle down for a certain duration of the time. So after the duration of the time, they are separated with each other and get settled down. How they are defined? They are defined on the base of their color. They are identified on the base of their color band. We see that these are the band of xanthophenyl beta. Alpha group, beta group, alpha 1 and alpha 2. There are different type of. This is a component we called as a phytoconstitution of any plant. Now this is a diagrammatic way. Now this is the type of compounds. Now in this way we are consider this is a calcium powder. Okay, a calcium carbonate powder or chalk powder. You just feel all in the cylindrical shape of the column, this column, and after some time you just added your samples which is having a different type of compounds and just let it be for a certain duration of hours, maybe 2 hours or 3 hours. After some time you will feel that these bands will be formed because how much compound is composed in your solvent, and later on one by one you can remove from here, from the funneling use with this type of the funneling compound, and just remove first one, then second one, third one, fourth one, fifth one with the different containers. So this is very simple technique we called as a column chromatographic technique. Through this column chromatographic technique you can easily separate your compound by using column chromatographic technique, separation technique. Now this time the same thing, you just added in your this is called as a stationary phase. Whatever you are adding here, this is called as a mobile phase. when the stationary phase and the mobile phase giving their certain chemistry in between that, and the mobile phase carry a component, they can retain on the stationary phase, and when they retain, they forming a different type bond. Now this is a combine of the two compound. This is a, this is a B. You feel that, you can feel the orange plus red is somehow, sorry, yellow plus reddish somehow get separated, but not exactly, but after some time, and depend on the retention time of your solutions on the stationary phase, how they will take, and later on you can feel that this is a separation of these two get easily defined and identified. Okay, so the development of chromatography, definitely it is a very slow for reasoning to be discussed later. Why it is a slow? The scientists have earlier lot of times they have defined the first chromatographic instrumental to appear in the market is the gas chromatography. Instead of the liquid get separated, the gas separated is much more easier and faster compared to the liquid. When they invented the gas chromatography, later on they defined कि liquid chromatography also we can design. So they accepted in such a performance with the 50s of trials. They do after the 2 decades, they invented or introduced the liquid chromatography after the gas chromatography. So in this way, the gas and the liquid get introduced. Now the gas is what? The gas is when the combination of the two gases or three gases in a solvent or in a gas component, and you just push into the column chromatography. The column chromatography also it acts as a stationary phase, and after the sometimes there is a maybe a deposition of the gases get trapped in the column, and we can remove by your before discussions in this way like a liquid chromatography. Okay, but here the lot of pressures we have to need because the gas needed certain ionized pressure in that. Okay, so this is the gas and liquid chromatography. Now generalize what type of the chromatography is designed. Liquid chromatography we call it as LC, L and C. Mobile phase is a liquid. Gas chromatography GC, mobile phase is the gas. Supercritical fluid chromatography, that is SFC, the mobile phase is supercritical fluids. Now what is the specification? The liquid we used, the gas and liquid we used, gas bonded phase we used, gas and solid also we used. The stationary phase, here the mobile phase is the supercritical fluid. Now the stationary phase is defined liquid chromatography, the liquid absorb on the solid. Just we took the examples, a calcium carbonate, a chalk powder on the first trial, whatever we have seen in the second or third slide, how the liquid get over chromatography. Now the liquid bounded phase, organic specific bounded to the solid surface. Now here the solid is also the stationary phase. Then ion exchange resin also the one of the stationary phase which is used in the ion exchange size exclusions. Then the liquid absorb on the solid, then organic species bonded to the solid surface. The gaseous means these are the restricted for the stationary phase we use in the gas chromatography. These all are used in the stationary phase, the liquid chromatography, whereas this is belonging to this. Now the what type of equilibrium? Equilibrium means what type of the mechanism is happening for the stationary phase with the mobile phase. In this way, the partially between immiscible liquids, immiscibles or miscible, that you know very well. Easily miscible means get together, and immiscible they are easily get separate from each other. And here the liquid founded a bond with the surface. On the surface side, liquid get adsorbed. So we observe the adsorption phenomena. Ion exchange is the partially or the sieving technique. Then the partially between the gas and the liquid is also we can see. Then partially between the liquid and bounded surface. Adsorptions again here on the solid the gas get absorbed, and the partially between supercritical fluid and hold it a surface. There is a one surface and supercritical fluid is available in the form of the mobile phase, and on that they are easily get absorbed. So these type of classification of chromatography, and you have to represent in this way, so you will get a very good marks for this. Now general descriptions means what? You feel that the separation chromatography having a different type of component in the samples, and that samples component are transport on the mobile phase. The mobile phase is either any absorption like a liquid or gas or supercritical fluid, anything. And the mobile phase we called as elute. The mobile phase penetrate. Penetrate means whenever the stationary phase is any kind of, we again consider the chalk powder is a stationary phase, and when your mobile phase is, you pour the mobile phase in the column type of the chromatography, and on the stationary phase there is a chances to get deposited some mobile phase on the stationary phase, and the rest of the mobile phase get move towards the end of the chromatography. So the solute in the samples, whatever elute means what? That you want to exactly isolate, that you want to exact separate from your sample. There are a lot of solute present in your samples and you want to just remove it. You want to just get separated. Now, how it is possible? Differential partitioning of this or interaction is maybe a one chance, and on the mobile phase with the stationary. The stationary phase is the fixed. This is not moving anywhere. And the solute, whatever having a strong interaction on the stationary phase, they are moved slowly. If you are taking a compound who is having a very good bond on the stationary phase, means stationary phase को चिपक जाएगा, stationary phase को stick होगा, उस टाइम पे उसको move होने के लिए slow होगा वो, as compared with the compound which is no having affinited toward the stationary phase. The compound having affinited to the stationary phase definitely move on slowly, and the retention time is high. So we will see what is the retention time, how we are designing, and the interaction अगर less है तो move fast हो जाएगा. Interactions means the molecule solute and the stationary phase का interaction slowly है तो वो move on fast हो जाएगा. So this type of defined chromatographical techniques and different type of migrations and solutes. The different type of migration compound, how the interaction the solute with the stationary phase, then where it is having, the mobile phase, what type of the polarity it has, the stationary phase, what type of the polarity it has. The solute don't want to stay on the stationary phase. It means it moves on fast down. So the chemistry in between the solute and the stationary phase is very, very important. The retention of or the interaction of the solute to the mobile phase to the stationary phase, that is exactly calculated with this technique. Now, in this, according to the nature of the mobile phase, the chromatographic technique are classified into the three. So we have already seen what type of the mobile phase, what type of equilibrium we have seen, and what type of the stationary phase is also available. So on the classification of that we will design in such a way a good type of the chromatographical we also used, but depend on what type of the samples you are targeted to get separate. If you want to separate gas, so you use a gas chromatography. If you want to separate a liquid, so you use liquid chromatography. If you have supernatant fluid, so you have to use a supernatant liquid. Elution chromatography is the same thing. There is a passing of the mobile phase inside these columns and the solute are carried out downward a stream. You just consider the column chromatography and differentiate the interactions of this on the stationary phase is goes on, and the continuation downward. The distance between solid band become a great with the time, and the solids start to leave sequentially. Whatever we have discussed on the column chromatography, so you feel that this is a moving of your solute and mobile phase, and this is a stationary phase. So in first time, this is a time taken. then time taken second one, time taken third one, and time taken fourth one on the across the column. So you have to decide it what type of these are we called as